So in this question we are given that a is equal to x square and b is equal to L sub z, right? And we are required to construct the uncertainty principle for the product of sigma A and sigma B. The second part is that we need to evaluate sigma sub B for the wave function for the hydrogen in this state, right? And the last part is that what can we conclude about the expectation value of xy in this state, right? So before solving all of these three parts, we must know that commutator of a comma b plus c is equal to commutator a comma b plus commutator a comma c, right? And the second thing that we must know is that the commutator a b comma c is equal to a comma c b plus a commutator b comma c, right? And the third thing that we must know is that the Jacobi relation, right? That is the commutator of p sub I and r sub j is equal to I h cross I j, right? Now over here I this I is basically x, and it can be equal to x or it can be equal to 0, can be equal to y, right? And from here we get that rx, because right we have p sub I and r sub j, so rx would be equal to x, r sub y, r sub y would be equal to y, and similarly r sub z would be equal to z, right? So the next point that you should remember before solving this question is that the average value of an operator in a state is given by expectation value of the um, operator, right? Expectation value of psi commutator a, not sorry commutator, it's not commutator, right? So it is equal to this one. Now let's start off with the solution of this question, right? So for part A, we need to construct a construct the uncertainty principle for sigma a sub a times sigma sub b, right? So we will begin solving the problem by calculating the commutator of the two operators that we have in the problem, right? That are um, a and b, right? These two are the operators, so we need to calculate their commutator. So commutator AB is equal to x square L sub z, right? That is the given information that we have, right? So now we are going to use some commutator techniques, some computer algebra over here, and we are going to manipulate this right hand side of the equation. So we have x square, right? It would remain the same. So over here we will have y px negative x p sub y, right? So now how we have done this is basically um, I have done it from using all of these 1, 2, 3, and 4 points that I just discussed about, right? That you must remember before solving this question. So now what I'm going to do is that from equation 1 and 2 you can get that it would be um, equal to x square y px plus y x square p sub x negative, since I'm running out of space over here, so I'm going to write in the next line, right? So x square x py negative x x square p sub y, right? So this would be 0 plus y x x px, right? I'm doing nothing very technical over here. I'm just using the basic commutator techniques, right? Basic commutator algebraic techniques that we just discussed above or earlier, right? I'm just using them. So negative 0 negative, then again I'm running out of space, so I'm going to write the rest of the term in the next line. So we have x comma p sub y plus x p sub y x, right? So now this would be y x negative I cross h plus negative I cross h times x negative x 0 plus 0, right? So when you'll solve them, or when you will simplify them, you will get that the commutator of AB is equal to negative 2i h cross yx, right? Um, but from equation 3.62, we have sigma sub a square times sigma sub b square, that is greater than or equal to 1 divided by 2i a comma b square, right? So from here we would what we would do is basically we have the commutator value of AB, right? So we are going to plug it in so that we get sigma a square sigma sub b square greater than or equal to 1 divided by 2i negative 2i h cross x y square, right? So but we need to find out the value of sigma a sigma b, right? So it means that we need to get rid of these squares over here, right? So for that we would apply an algebraic technique, and we would get that sigma sub a times sigma sub b is greater than or equal to h cross expectation value of xy, right? So this is your solution for part A, right? So now the next part, that is part B, right? So for part B, we needed to evaluate sigma sub B in the hydrogen state, psi and LM, right? So what we need for that is basically the expectation values of LZ, right? And LZ square, right? So in some arbitrary hydrogenic normalized state, let's say that is psi sub NLM, fine. So to evaluate the variation in B, right? So sigma sub B would be found out by that the expectation value of B is equal to expectation value of L sub Z, right? So uh, next we are going to write it in this form. So we have M H cross psi, right? So as this is constant, so we can write it outside. So we have psi, right? So it would be 1, right? So we would be left with M times H cross, right? Similarly, we would find out the expectation value for B square, right? So that would be equal to expectation value of L Z square. Fine. So psi L Z square psi. So that is equal to psi M square H cross square psi, right? So again, this term is constant, so we can write it outside. So we would be having m square h cross psi psi, right? Now again, this would be equal to 1. So we would be left with m square h cross, right? So this would be the expectation value of b square, right? And this was the expectation value of b. Fine. So now what we are going to do over here is that we are going to use both of these um, values, right? And we would plug them in an equation for sigma sub b. Fine. So sigma sub b is equal to under root expectation value of b square negative expectation value of b square, right? So plugging in the values and you would have m square a square negative m square h square. So that would be equal to 0, right? So from here we conclude that sigma b is equal to 0. So this was the solution for part b. Now the next step is that we need to find out the um, solution for part C, right? So in part C, we needed to conclude that what do we have the information, what information do we have about the expectation value xy in this rate, right? So from part B, right, we see that the variation in B, or that is sigma B straight, right? So that is basically equal to 0. And the right hand side of the uncertainty principle that we obtained in um, in part A, right? That was h cross expectation value xy, right? So now this would be always positive, right? So um, it's always positive, and the variation in B is equal to 0, right? So it means that the right hand side of the insanity principle, it must also be equal to it must also be equal to 0, right? So we conclude from all of this information, we conclude that expectation value of xy is also equal to 0, right? So this is your solution for all of the three parts that were required by us to solve in this question. So thank you very much for watching the video.